आई सी। चलिए शुरू करते हैं। तो मैकेनिक्स का हम एक, इज इट बीइंग शेयर्ड? आसपास रही है। ये वाला हटाना। ओके, सो लेट्स स्टार्ट। तो लास्ट क्लास में हमने कोलिजन्स वगैरह के क्वेश्चंस शुरू किए, और मैंने आप लोगों को बोला था कि वो वीडियोस देखिएगा। आप लोगों ने देखे एंगुलर मोमेंटम?
यस सर।
चलिए क्विकली, अगर मैं आप लोगों से पूछूं कि एक पॉइंट मास है और ये पॉइंट मास v वेलोसिटी से चल रहा है, ये m मास है, इसका इस पॉइंट के अबाउट एंगुलर मोमेंटम क्या है? इस पॉइंट से इसका लाइन ऑफ वेलोसिटी से परपेंडिकुलर डिस्टेंस इज, ये लाइन ऑफ वेलोसिटी है, इससे जो परपेंडिकुलर डिस्टेंस है वो d है। ये
आर
ये
क्रॉस एम वी।
d परपेंडिकुलर। हाँ, सो एंगुलर मोमेंटम ऑफ अ पॉइंट मास क्विकली समझ लेते हैं। कोई भी वेक्टर ज्वाइन करिए इस पॉइंट से इसकी लाइन ऑफ वेलोसिटी पे, कहीं पे भी ज्वाइन कर लीजिए। ये लीजिए, मैंने ये ले लिया। अगर इस वेक्टर को बोलूं आर वेक्टर, तो एंगुलर मोमेंटम ऑफ अबाउट पॉइंट पी ऑफ दिस पॉइंट मास इज डिफाइंड एज आर क्रॉस पी। करेक्ट। सब लोग ध्यान से देखिए, जब आप इसको क्रॉस प्रोडक्ट को सॉल्व करेंगे, सिंप्लीफाई करेंगे, तो ये आ जाएगा आर क्रॉस एम बी, which will finally come out to be m into v into perpendicular distance। ये ही आएगा, कहीं पे भी लीजिए। इसकी एक डायरेक्शन है, वो डायरेक्शन एन कैप बोल देते हैं। अब आर क्रॉस बी की डायरेक्शन बताइए क्या होगी? कैन एनीवन एक्सप्लेन? आर क्रॉस बी की डायरेक्शन इनटू द प्लेन या आउटसाइड द प्लेन? जब भी आपको क्रॉस प्रोडक्ट निकालना है दो वेक्टर्स का, दोनों की टेल्स को एक जगह ले आइए। वी को हमने शिफ्ट कर लिया ऐसे यहीं पे, और आर हमने ले लिया यहाँ पे। दोनों की टेल्स, वी कैन शिफ्ट अ वेक्टर पैरेलल टू इटसेल्फ एनीवेयर इन स्पेस। ये आर वेक्टर हो गया, ये वी वेक्टर हो गया। आर क्रॉस वी करेंगे तो यूं घुमाएंगे, ऐसे घुमाने पे स्क्रू विल गो इनटू द प्लेन। सो डायरेक्शन आपकी आ गई इनटू द प्लेन, ऐसे ये डायरेक्शन है। ठीक है, नाउ एन कैप की ये डायरेक्शन है इनटू द प्लेन। ये जिन बच्चों को समझ में आ गया, गिव मी अ थम्स अप। आई जस्ट वांट टू बी श्योर कि ये वाली सिंपल चीज एंगुलर मोमेंटम ऑफ अ, ये हम बात कर रहे हैं एंगुलर मोमेंटम ऑफ अ पॉइंट मास, एक पॉइंट मास का एंगुलर मोमेंटम अबाउट अ पॉइंट पी। जिन बच्चों को ये समझ में आ गया है, थम्स अप। ठीक है, इनटू द प्लेन। गुड ना लवन्या। नाउ अब हम आगे चलते हैं। अगर मेरे पास एक पॉइंट मास की जगह एक रिजिड बॉडी हो, मान लो मेरे पास ये हो, ऐसी कोई रिजिड बॉडी, स्फीयर, रॉड, सिलेंडर, ये सारे केसेस होते हैं। अगर वो मूव कर रही है वी वेलोसिटी से, तो उसका सेंटर ऑफ मास मूव कर रहा है वी सी एम से, और वो अपने सेंटर ऑफ मास के अबाउट रोटेट कर रही है किसी भी एंगुलर वेलोसिटी ओमेगा से, सपोज ओमेगा सी एम। ये सेंटर ऑफ मास है ना। इसका एंगुलर मोमेंटम अबाउट पॉइंट पी कितना होगा? ये पॉइंट पी है स्पेस में कहीं, कैसे निकालेंगे बताइए?
स्पिन प्लस ऑर्बिटल।
हाँ, स्पिन प्लस ऑर्बिटल। स्पिनिंग, अगर ये मूव नहीं कर रही होती सेंटर ऑफ मास, ये वेलोसिटी नहीं होती बाई चांस, तो ये सिर्फ यहाँ पे प्योर रोटेशन कर रही होती है इस एक्सिस के अबाउट। और अगर प्योर रोटेशन कर रही होती तो इसका स्पिनिंग हो रही है अपने सेंट्रोइडल एक्सिस के अबाउट। अगर इसके अबाउट मोमेंट ऑफ इनर्शिया आईसीएम है, तो आप स्पिन एंगुलर मोमेंटम लिखते एल स्पिन, कि ड्यू टू दिस स्पिन जो एंगुलर मोमेंटम है वो होता आईसीएम इंटू ओमेगा सी एम। ये स्पिन एंगुलर मोमेंटम हो गया। ठीक है। अब अगर ये पूरी बॉडी को मैं एक पॉइंट मास मान लूं और सारे मास को यहां सेंटर पे रख दूं, एम मास रख दिया, ये एम मास, और ये वीसीएम से चल रहा है, और इसको एक पॉइंट मास मान लूं जो अभी पीछे हमने किया है कि एम मास वी वेलोसिटी से चल रहा है। ये रहा, ये वही एम मान लो इसे, और ये वी वेलोसिटी से चल रहा है। नाउ इसका जो एंगुलर मोमेंटम है, ये जो निकाला हमने पॉइंट पी के अबाउट, वो और निकाल दीजिए इस रिजिड बॉडी के लिए, कि पूरी बॉडी को श्रिंक करके एम मास को यहां पे कंसंट्रेट कर दिया सेंटर ऑफ मास पे, और ये वी वेलोसिटी से चल रहा है, तो आप क्या करेंगे, एम वी इंटू ये वाला परपेंडिकुलर डिस्टेंस, ये वाला, या फिर आर क्रॉस एम वी, वट एवर। उसको हम ऐसे भी लिख सकते हैं कि अगर हमने कोई भी इसको यहां ज्वाइन कर लो और इस वेक्टर को बोल दो ये वेक्टर है आर, तो आर क्रॉस एम वी, आर क्रॉस पी, दिस विल बी ऑर्बिटल एंगुलर मोमेंटम बोलते हैं इसको, एल ओ। इन दोनों का सम, वेक्टर सम विल गिव यू द टोटल एंगुलर मोमेंटम ऑफ द रिजिड बॉडी। ये जिन जिन को समझ में आ गया कि ये जो कहानी बताई गई है फॉर अ रिजिड बॉडी, ये मुझे समझ में आ गई, अब इसको हम रॉड, डिस्क, बाकी सब चीजों के लिए करेंगे, और कुछ कॉम्पिटेटिव एग्जाम में आए हुए क्वेश्चंस करेंगे क्विकली। तो इसे, जिनको ये समझ में आ गया है एंगुलर मोमेंटम ऑफ अ रिजिड बॉडी कैसे लिखते हैं, उसकी अपनी एक्सिस के अबाउट, जो धुरी के अबाउट जो स्पिन कर रही है उसे लिख लेते हैं, आईसीएम ओमेगा सीएम, वो कहलाती है स्पिन एंगुलर मोमेंटम। और जो उसके सेंटर ऑफ मास के मूव करने की वजह से जो ऑर्बिटल एंगुलर मोमेंटम आ रहा है इस पॉइंट के अबाउट, वो हमने निकाला आर क्रॉस एम वी से, और इन दोनों का वेक्टर एडिशन विल गिव मी टोटल एंगुलर मोमेंटम एल फॉर दिस रिजिड बॉडी अबाउट पॉइंट पी, एल पी। नाउ अब मैं आपसे, जिन जिन बच्चों को ये समझ में आया, एक बार फिर से थम्स अप दो, आई वांट टू बी श्योर। अब इसके ऊपर क्वेश्चंस करते हैं, और कोलिजन में ये काफी यूज होता है, तो इसलिए बहुत जरूरी है समझना। आगे चलते हैं, चलिए, गुड। अब मैं अगर आपको एक रॉड दूं, ये ये स्फीयर है, चलो, ऑफ रेडियस आर, एम मास, एम मास आर रेडियस, और ये सॉलिड स्फीयर है, और ये सॉलिड स्फीयर ग्राउंड पे ना ऐसे चल रहा है, प्योर रोलिंग करते हुए। अच्छा, सुपर इम्पोजिशन थ्योरम भी पता होना चाहिए आपको, कि अगर कोई भी रिजिड बॉडी हो, ये बड़ा इंपॉर्टेंट है, ये आपके रोटेशन की प्रॉब्लम्स में बहुत यूज होता है, कि अगर आपकी कोई भी रिजिड बॉडी है और वो बॉडी वीसीएम से चल रही है, ये रोटेशन का एक थ्योरम है, इसे सब बच्चे लिख लें, और अगर उसकी एंगुलर वेलोसिटी है ओमेगा सीएम, किसी भी एक्सिस के अबाउट, तो आप उसका किसी भी पॉइंट की वेलोसिटी निकाल सकते हैं। कैसे निकालेंगे इस पॉइंट की वेलोसिटी? अगर ये रिजिड बॉडी सिर्फ ट्रांसलेशन कर रही होती, सिर्फ वीसीएम से चल रही होती, तो इस पॉइंट की वेलोसिटी भी, हर एक पॉइंट की वेलोसिटी वीसीएम होती, तो इसकी भी वीसीएम होती वेक्टर में। और अगर कोई बॉडी सिर्फ रोटेशन कर रही है अपनी किसी एक्सिस के अबाउट, और आपको एंगुलर वेलोसिटी दी हुई है ओमेगा, तो आपने वो सीखा हुआ है कि वी ऑफ दैट पॉइंट, रिजिड बॉडी के पॉइंट की v इज इक्वल टू ओमेगा क्रॉस आर। ये अगर आर वेक्टर है, उस पॉइंट को आर पोजीशन वेक्टर विद रिस्पेक्ट टू सेंटर ऑफ मास आर ले लूं, तो ओमेगा क्रॉस आर ये होता है ड्यू टू रोटेशन, वी विल बी ओमेगा क्रॉस आर। ये वेक्टर फॉर्म में सिखा रहा हूं इसलिए थोड़ा टफ लग रहा होगा समझना। तो नेट वेलोसिटी जो आएगी, ये v2, ये रोटेशन की वजह से है, ये ट्रांसलेशन की वजह से है, और दोनों का वेक्टर सम, आप रोटेशन की वजह से जो वेलोसिटी आई वो भी कुछ आएगी ओमेगा क्रॉस आर करके, और ये वीसीएम, इन दोनों का वेक्टर सम, सो वीसीएम ट्रांसलेशनल वेलोसिटी प्लस जो रोटेशन की वजह से है ओमेगा सीएम क्रॉस आर, दिस इज द नेट वेलोसिटी ऑफ पॉइंट पी। तो रिजिड बॉडी के कभी भी किसी पॉइंट की वेलोसिटी या एक्सेलरेशन निकालनी हो, तो आप सुपर इम्पोजिशन थ्योरम लगाते हैं, जिसको बोलते हैं सुपर इम्पोजिशन थ्योरम, और ये हर बच्चे को पता होना चाहिए। और इसकी बहुत जगह यूज आती है, इसलिए मैं टॉपिक से अलग हटके इसको एक्सप्लेन भी कर रहा हूं। नाउ अब देखिए इसका यूज कैसे आएगा। एक स्फीयर प्योर रोलिंग करते हुए चल रहा है, मान लीजिए मैंने बोला उसकी वेलोसिटी है VCM, ये दी हुई है, इतनी वेलोसिटी से चल रहा है। अब मैं अगर आपसे पूछूं ये प्योर रोलिंग, ग्राउंड पे प्योर रोलिंग करते हुए चल रहा है, इसकी ओमेगा कितनी होगी, ये बताओ जरा, ओमेगा कितनी होगी। देखिएगा, तरीका देखिए। अगर ये चल रहा है ग्राउंड पे, तो इस स्फीयर का जो पॉइंट है, एक पॉइंट तो स्फीयर पे है, ये रहा, स्फीयर का पॉइंट S बोल देता हूं। और जो ग्राउंड का पॉइंट है, उस ग्राउंड के पॉइंट को मैं G बोल देता हूं, जो कांटेक्ट में है उसके, G। ये दोनों पॉइंट्स की वेलोसिटी अगर स्लिपिंग नहीं हो रही, प्योर रोलिंग करते हुए चल रहा है तो स्लिपिंग नहीं हो रही इन दोनों के बीच में, ग्राउंड के पॉइंट की वेलोसिटी क्या है, इसकी वेलोसिटी है 0। ग्राउंड पे जो पॉइंट है, अगर ग्राउंड के पॉइंट की वेलोसिटी 0 है, तो ये जो स्फीयर है, इसकी वेलोसिटी हम निकालते हैं सुपर इम्पोजिशन से, कि भाई ट्रांसलेशन की वजह से VCM है इधर, और रोटेशन की वजह से ये डिस्टेंस है R, रोटेशन की वजह से पीछे की तरफ है। देखो, अगर ये खाली रोटेट कर रहा होता, तो रोटेट होने पे, ऐसे रोटेट होने पे इसका लोएस्ट पॉइंट ऐसे जा रहा होता यूं, और कितनी वेलोसिटी से, R ओमेगा से। तो इसकी नेट वेलोसिटी क्या हो गई, इस पॉइंट की, S पॉइंट की नेट वेलोसिटी हो गई VCM माइनस R ओमेगा CM, ये हो गई। और दिस शुड बी इक्वल टू 0, क्योंकि ग्राउंड के पॉइंट की 0 है, क्योंकि हमने कहा है कि भाई प्योर रोलिंग हो रही है, तो इन दोनों पॉइंटों के बीच में स्लिपिंग नहीं हो रही, यानी कि जो वेलोसिटी ग्राउंड के पॉइंट की है वही वेलोसिटी इस पॉइंट की होनी चाहिए, इसलिए हमने उसको 0 रख दिया। अब 0 रखने पे कंडीशन आ गई VCM शुड बी इक्वल टू R ओमेगा CM, और यहां से ओमेगा निकल गया, ओमेगा कितना आ गया, 20 VCM अपॉन R। तो एक तो आपको ये पता लग गया। ये जिन बच्चों को समझ में आ गया कि ओमेगा इतना होगा और ये कंडीशन ऐसे आई है, वो मुझे थम्स अप दो, क्विक। आई वांट टू बी श्योर कि आपको ये समझ में आता जा रहा है जो मैं बता रहा हूं। ये V इज इक्वल टू R ओमेगा की कंडीशन सुपर इम्पोजिशन लगा के कैसे आई, और ओमेगा कैसे निकाली हमने, वो जिन जिन बच्चों को समझ में आ गया है थम्स अप दीजिए। ठीक है। नाउ सूरज, सुप्रज, प्रकाश, लावण्या, ठीक है। अब देखिएगा, अब मैं थोड़ा सा लेवल बढ़ाऊंगा और थोड़ा इंटरेस्टिंग चीजें करेंगे। अब इसी स्फीयर का, ये जो स्फीयर प्योर रोलिंग करते हुए जा रहा था, इस स्फीयर का आप मुझे बताएंगे कि इसका एंगुलर मोमेंटम लिखना है मुझे। क्या लिखना है, मैंने बस इतना बताया आपको कि भाई ये V0 स्पीड से चल रहा है प्योर रोलिंग करते हुए ग्राउंड पे, ये बताया मैंने, और इसका मास M है और रेडियस R है। अब आप मुझे बताएंगे, पहला पॉइंट बताएंगे कि इसका एंगुलर मोमेंटम अबाउट सेंटर ऑफ मास, ये सेंटर ऑफ मास है, ये जो पॉइंट ऑफ कांटेक्ट है ग्राउंड पे, उसका नाम रख दिया G, ग्राउंड के पॉइंट का। और एक मैं पॉइंट ले रहा हूं यहाँ पे, ओरिजिन कुछ नाम दे रहा हूं, O, ऐसे। ये 3 पॉइंट्स के अबाउट, एक एक पॉइंट है ये C, एक पॉइंट है G ग्राउंड, और एक पॉइंट है O ओरिजिन, काफी दूर है। और इसका रेडियस है R स्फीयर का, ये V0 स्पीड से चल रहा है और प्योर रोलिंग करते हुए चल रहा है, ये मैंने बता दिया। तो विल इट हैव सम एंगुलर वेलोसिटी, यस और नो, ओमेगा होगी या नहीं। हॉरिजॉन्टल प्लेन है ये, हॉरिजॉन्टल, मैंने थोड़ा टिल्टेड बनाया। तो प्लीज रिप्लाई, बच्चों कम बच्चे हैं, यू कैन बी पार्टिसिपेटिव, सो मुझे ये लगता रहेगा कि आपको समझ में आ रहा है। हॉरिजॉन्टल प्लेन है और ये प्योर रोलिंग करते हुए चल रहा है, ये मैंने कंडीशन दे दी है, प्योर रोलिंग करते हुए चल रहा है, तो ये ओमेगा होगी या नहीं, और ओमेगा कितनी होगी अभी निकाली हमने, कितनी होगी बताइए, कंडीशन ऑफ प्योर रोलिंग। ये है, ये निकल गई, ये सबको पता है। अब मेरा सवाल आपसे है कि इस बॉडी का फर्स्ट पार्ट है एंगुलर मोमेंटम अबाउट सी, बताओ, सेंटर ऑफ मास। सेकंड क्वेश्चन है एंगुलर मोमेंटम अबाउट जी, बताओ। एंड थर्ड पॉइंट है एंगुलर मोमेंटम अबाउट ओ, बताओ। इस रिजिड बॉडी का ये जो स्फीयर है, ये सॉलिड स्फीयर है। सॉलिड स्फीयर के लिए मोमेंट ऑफ इनर्शिया कितना होता है? 2/5 mr² या 2/3? बताइए। हम्म ये तीनों एंगुलर मोमेंटम बताइए कितना होगा। जब आपको एंगुलर मोमेंटम समझ में आएगा तो आप कोलिजन, बहुत सारी जगह पे इसकी एप्लीकेशन होती है और सब क्वेश्चंस को कर पाएंगे। तो मेरी रिक्वेस्ट है कि फटाफट आंसर करिए। एल सी तो बहुत आसान, सब बता सकते हैं। बताइए कितना होगा एंगुलर मोमेंटम अबाउट सेंटर ऑफ मास। चिल्ड्रन, यू, आपको रिप्लाई देना होगा, आपको आंसर देना होगा। मोमेंट ऑफ इनर्शिया मैंने बता दिया है आपको, 2/5 mr² होता है। एंगुलर मोमेंटम कितना होगा सेंटर ऑफ मास के अबाउट? जीरो नहीं होगा, जीरो नहीं है, रॉन्ग आंसर। और बताइए।
एमआरओ।
हाँ, बोलो बच्चे। देखो, इस स्फीयर के लिए सेंटर ऑफ मास के अबाउट स्पिनिंग हो रही है, और वो स्पिनिंग हो रही है ओमेगा से, स्पिन कर रहा है। तो एंगुलर मोमेंटम होता है ICM ओमेगा CM। सेंटर ऑफ मास के अबाउट मोमेंट ऑफ इनर्शिया इतना है, ये है ICM। तो सिर्फ इतना लिखना है आपको, ICM 2/5 mr² इंटू ओमेगा CM। ओमेगा इतनी है, ये रही, V0/R। And it has a direction also. The direction should also be very clear. N cap. N cap will be, if it is rotating in this direction, it is into the plane. यानी कि into the plane. Arrow going inside the plane. So N cap is into the plane. Okay. How many of you understood this? So it will only have spinning happening, and this is the angular momentum about center of mass. ऑर्बिटल एंगुलर मोमेंटम ऑफ द सेंटर ऑफ मास देखिए जीरो है। ऑर्बिटल क्यों? एम यहां पे, एम इंटू वी। अब व्हाट इज द परपेंडिकुलर डिस्टेंस ऑफ द सेंटर फ्रॉम द सेंटर इटसेल्फ, क्योंकि वी आर फाइंडिंग एंगुलर मोमेंटम अबाउट दिस पॉइंट ओनली, दिस पॉइंट ओनली। So perpendicular distance is zero. Therefore, orbital is zero and spin is this. How many of you understood this correct? Please give me. How many of you understood this angular momentum? Give me a thumbs up. Those of you who understood angular momentum of a sphere about center of mass will be this, which I explained. Please give me a thumbs up. Hmm. Good. I think I now you have to tell me what will be the angular momentum about point G, ground. So angular momentum about point G will be ICM omega CM, spin angular momentum as it is, this term will come, plus orbital angular momentum. Orbital angular momentum will be MV, M into V naught into perpendicular distance from that point, and that is R. So M V naught into R, and that is also clockwise. देखिए, it is moving like this, so it is clockwise. So this plus this, ye bhi is into the plane of the board. So they will get added, and this will be the total angular momentum about point G. Those of you who understood this, please give me a thumbs up. Vishwas Nayak, N Vishwas Nayak. Did you understand it? These are very important things which everyone should be clear. If your angular momentum is weak, you cannot. Okay, Lavanya, ठीक है. And the last one, I want to find angular momentum about this point. This point. How do I find it? Again, the same thing. Spin angular momentum will still be ICM omega CM. This is I 2 by 5 mr square into omega CM. This is the spin angular momentum. It is into the plane of the board. Plus, line of velocity is this. Perpendicular distance from this point on the line of velocity is again r. So that is also going to remain the same mvr. Again, it is in clockwise direction. So angular momentum about point G and about point O, or any point you choose here on the ground, will be same. And it'll be this. Angular momentum about center of mass, I already explained, will be this. There will be no orbital angular momentum, and all of you are expected to know this. Those of you who understood this, LO, Lavanya is asking, O is a fixed point on the ground. Yes. So now let me ask you another question. I have a rod hinged here, and I have left it from rest. When it reaches the lowest position, when it will reach the lowest position, it will have some angular velocity. M is the mass of the rod, L is the length of the rod. It will have some angular velocity. Can you tell me what will be that angular velocity? कितनी होगी? देखते हैं कौन बताएगा. Can I conserve energy? Quick. Can I do energy conservation? To find omega, yes, we can. We can conserve energy because there is no work being done by any dissipative force. There is no friction happening. So all the gravitational potential energy loss, the center of mass of the rod was here. It reached from here to this point. L by 2 is the height it lost. mgl by 2, loss in gravitational potential energy, is equal to gain in kinetic energy. Kinetic energy of a rod, about, we can assume the rod to be doing pure rotation about this axis. So this will be half I about that axis will be ml square by 3, half I omega square. That's it. From here, when you cancel this, you will get 3g by L. This will be the answer. This will be the angular velocity. How many of you understood this? Give me a thumbs up. Okay, Pratik, Rastogi. Who else? Now I am going to ask you a question. My question is, what is the angular momentum? Arham Shah, Vishwas Nayak. Okay, quick. Now tell me, what is the angular momentum of this rod at the lowest position? When the rod is at the lowest position, what is the angular momentum of this rod? Quickly, we have to write the expression. So angular momentum about which point? First, you have to be very clear about the point you are trying to find out the angular momentum about. Suppose I tell you angular momentum about this axis I want to find. So angular momentum will be I into omega. I about that axis is ml square by 3 into omega. That's it. This will be the angular momentum about L. And what will be the direction of angular momentum? into the plane. N cap, N cap is into the plane, like this. You can see it is rotating clockwise, and I am assuming that you know clockwise rotation is into the plane. Okay. This is the angular momentum. Now, if I tell you it collides with another mass here, which was at rest, यहाँ पे मान लीजिए रॉड गिरते गिरते ऐसी पोजीशन में आई, एंड नाउ इट कोलाइड्स with a mass which is m by 4. Rod mass is m, the mass of this point mass is 4 m by 4, and it is kept on a horizontal table like this, and the rod ka ye wala end will hit this, and I say collision is perfectly elastic collision. So what will be the new angular velocity of the rod after collision? What is the velocity of this point mass after collision? It will have some velocity. What is that? V dash. Initially it was 0. How do you solve this? So we are doing miscellaneous problems. First I did a question where you had to conserve energy. Then I asked you to explain to me. We found angular momentum of the rod. And now we are doing a collision problem based on the same situation. Now, tell me, can I conserve linear momentum? Yes or no? Of the rod and point mass? Answer has to be in yes or no. Can I conserve the angular momentum of the rod and the point mass? Sorry, linear momentum. Children, you have to respond. I am not able to hear you or hear anything from you, so that demoralizes me whether you are understanding or not. I can accordingly tune in the level. I can do easy stuff. I can explain things from scratch, but that will happen only when I know you are understanding or not understanding. Okay. How many of you are understanding things? Okay. Two. Please. Parth. No. So can you unmute yourself and explain to me? So accordingly, I will Vishwas Nayak. Hmm. Okay. The the yeah, there will be a sudden jerk, and therefore there will be a force acting here, which will be acting in this direction. देखिए, जब ये दोनों एक दूसरे से कोलाइड करेंगे, ये पॉइंट मास और ये एंड ऑफ द रॉड, तो there will be a sudden force acting on the between them. That force will be like this. इस पे इधर लगेगी, sudden force इस पे इधर लगेगी. Now, that force will produce a jerk in the rod, and there will be some normal reaction acting here, nx, ny, whatever. So there will be an external force. External force होगी, so we cannot conserve linear momentum. So linear momentum won't be conserved, because there is an external force. This is that external force in the hinge, which is acting in horizontal direction and is not a part of the rod and point mass. वो बाहर से हिंज लगा रही है उसके ऊपर. सो एक्सटर्नल फोर्स लग रही है, इसलिए वी कांट कंजर्व लीनियर मोमेंटम. कैन आई कंजर्व एंगुलर मोमेंटम अबाउट द हिंज? यस और नो? कैन वी कंजर्व एंगुलर मोमेंटम अबाउट द हिंज? Parth, Lavanya, yes, we can. So we'll conserve angular momentum. Let us write down the equation. Initially, angular momentum of the rod was this, and for the point mass was 0. It was at rest. So this is the total angular momentum of the system initially before collision. After collision, I am assuming the rod is moving in the same direction with some velocity omega 1, omega dash, and this point mass moves with a velocity v dash. Now, angular momentum of the rod will now become ml square by 3 into omega dash. This is the angular momentum of the rod. Plus, angular momentum of the point mass will be m by 4, m into v dash into perpendicular distance, or perpendicular distance has to be this. This is the perpendicular distance. Point mass and this hinge, they are at a perpendicular distance of how much? L. So mv dash into L. Now, this will be angular momentum of the point mass. Both are clockwise. Point mass is also moving in this direction. Rod is also rotating in this direction. Both are clockwise. So they are in the same direction. We can add them as numbers. Now, this should be the final angular momentum and they both should be equal. So we conserved angular momentum. This is one equation. This should be equal to this. Okay. We have two unknowns, omega dash and v dash. We have got one equation. The other equation can be energy or coefficient of restitution, which will be more preferred. Which equation should we prefer? Coefficient of restitution wali या energy wali equation? E equation. Let's write down the E equation. 1. Coefficient of elasticity for perfectly elastic collision is 1. Should be equal to minus. Let's name these points. I am naming this point as 2. This is 2 rod. And this point is 1. Now, after collision, what is the velocity of 2? V2 is L omega dash minus what is the velocity of point mass? It will be V dash. V2 minus V1 upon U2 minus U1. U2 was L omega minus U1 was 0. Ball was at rest. This is the second equation. Now we have got this is one equation, this is second equation. These two equations, two unknowns, we can solve it. How many of you understood this? Please give me a thumbs up or write it down. Lavanya, who else? Supraj, good. Apsana, good. Masira, good, good, good. If you are able to understand till here, you are a serious candidate doing good in your acads. Now let's do this question quickly. If I tell you there is a string and a point mass is hanging with a string like this, mass is m1. It is hanging from the roof. There is another point mass which will come and hit this. This point mass is m2 and it is going to go and hit it with a velocity u0. These are given. I can give you the values, but right now I don't want to do calculations and just make you understand the concepts. And the collision is head on. This is the horizontal line. Now, if I do this collision, this is not a rod. This is a string this time. There is a difference between this. It is a string hanging vertically. And there is a stone tied to this string whose mass is m1. This is again a perfectly elastic collision. Perfectly elastic collision. And I have asked you what will be the velocities of both m1 and m2 after collision. You have to find that m1 was at rest, m2 was coming with velocity u0 in this direction and goes and hits it horizontally, heads on collision, identical balls. Now, find the velocities after collision. This is the question. Try to do it. करिए. अब मेरा क्वेश्चन है यहां पे, कैन आई कंजर्व लीनियर मोमेंटम? क्विक, yes or no? Your answer has to be a yes or no. Can I conserve the linear momentum of both the masses in horizontal direction? Can I conserve the linear momentum? Mallikarjun, are you getting it? You have to tell me. Can I conserve linear momentum? So let's assume after collision, the velocity of m1 is v1. After collision, velocity of m2 is v2 in the same direction. It may happen that v2 may be in opposite direction, but we don't need to worry about it right now. If v2 has to be negative, if v2 comes out to be negative, that means it is going in opposite direction. Mallikarjun Panchal, can you hear me? Please try and tell me. आप लोग ट्राई करिए सॉल्विंग दिस. Giving you 2 minutes to solve this question. And I'll be very impressed if you just write the correct equations. L is the length of the spring. The string. Massless. Hmm. Okay, Mallikarjun, I'll talk to you. Just give me 1 minute. Okay. Let's solve it now. Everyone should be attentive because with these few questions, you will get full clarity about what to do in which case. So just see this. This is a string. Now there will be force of collision. When they will collide, this ball is going to exert a force on this in this direction, and it is going to exert a force on this in this direction. It will be a very large magnitude force which they will exert on each other. Now, but I can assume that force to be internal force. Collision force is between them is internal force. Now let's see, is there any force the string is exerting? Yes, there is some tension in the string, but that force is acting in vertical direction. And even though there is a sudden jerk, like previous question where we had a rod, but that jerk is in horizontal direction. That force is in horizontal direction, and the string यहाँ पे immediately there will be no sudden jerk past here because this is a string, not a rod. Now because it is a string, तो जो इस डायरेक्शन में फोर्स लगनी है ड्यू टू एक्सटर्नल फोर्सेस वो नेग्लिजिबल होगी अभी एट दिस इंस्टेंट. nx will be negligible, tending to zero, almost zero. It is zero. Now, therefore, we can conserve linear momentum. This is the difference. For a rod, if it was a rod, if AB was a rod, you can't conserve if AB is this point and B is this point. If it was a rod, rigid rod, then this force would have generated immediate jerk here and it would have been an external force. Therefore, we were not able to conserve linear momentum in horizontal direction, but now we can. Linear momentum can be conserved now because this is not a rod, this is a string. So linear momentum conservation equation will be m1 into 0 plus m2 into u naught. Yes, Parth had written that. m1 v1 plus m2 v2. m2 into u naught is equal to m1 into v1 plus, after collision, the velocities are v1, v2, m2 into v2. This is the equation for conservation of linear momentum. And why are we conserving linear momentum in this case? And why we were not conserving linear momentum in this case when there was a rod? You need to be very clear because in a rod, it is a rigid rod. The moment there is a force acting here, which is going to be sudden in this direction, this force, this force will create an immediate motion of every particle and there will be a jerk, and that jerk is an external force, nx. Whereas string doesn't create a sudden jerk at this point and there is no force here in horizontal direction. This is zero. Therefore, we conserve linear momentum. How many of you are clear about what I just said? Why we are conserving linear momentum in this string case and we were not conserving linear momentum in those who are clear about it. Parth Rastogi is clear. Give me a thumbs up. Lavanya is clear. Good. Who else? Give me a thumbs up, please. N. Vishwas Nayak. Supraj. Good, good, good. Now, these are questions which come in competitive exams. So once you get the hang of where to conserve what, now I'll do more questions and I'll be a little fast. And I want response so that I'm very clear. Uh, Lipakshi. Okay, good. Now, let's move. This is one equation. We have two unknowns. One unknown is this after collision. One unknown is this. What is their final velocity after collision? We need one more equation. What should be that equation? E, coefficient of restitution 1 should be equal to minus V2 minus V1. Yeah, V1 minus V2 upon U1 minus U2. Whichever you write first, here the same velocity, same body's velocity you have to write here. So I wrote v1. So the velocity of this point before collision was zero, of 0 minus u naught. This is our second equation. We have two equations and two unknowns. We can solve them. I am not getting into solving them because I want to focus on conceptual clarity right now. Okay, let's move fast. Another question. Will the angular momentum be also conserved? Yes or no about this point? About this point. Will angular momentum be conserved? Yes or no? Just give me an answer in yes or no. About hinge, about top, A point. Yes or no? Yes, Parth says yes. Angular momentum will be conserved. Arham says yes. Yes, yes. Lepakshi says yes. Yes. It will be conserved because there is no external force acting here. But conserving that also will not give me a new equation. Independent equation नहीं मिलेगी. आपको यही इक्वेशन मिल जाएगी उससे भी देखिएगा आप. सिर्फ आर एक्स्ट्रा ऐड हो जाएगा and you will still get this equation only. There will be no independent. So you have to either use conservation of angular momentum or linear momentum. Both will give you the right answer. Okay, correct. ठीक है. So we got two equations, two unknowns. We can solve this question. Then they ask you till what height will it rise? Okay भाई, अगर ऐसा है तो यू कैन आफ्टर दिस कोलिजन यू हैव फाउंड v1. अब आपसे पूछा जाए कि ये स्ट्रिंग कितनी हाइट तक जाएगा और कहां तक जाके रुकेगा, तो यू कैन फाइंड आउट व्हाट हाइट. यू कैन जस्ट कंजर्व एनर्जी. या कितना एंगल डिफ्लेक्ट होगा, विल इट कंप्लीट द फुल सर्कल और नॉट. ऑल काइंड ऑफ क्वेश्चंस कैन बी मेड एंड दैट वी हैव ऑलरेडी डन. अगर v1 इज greater than or equal to root 5 GL, it will complete the full vertical motion. ये रहा पूरा vertical circle complete करेगा. If it is greater than root 2 GL, root 2 GL is the velocity to reach here, horizontal level. और तो ये सब हमने पढ़ रखा है in circular motion, so I am not repeating that. Now we come to next question. Let's see. बच्चों, I just want to take out 5 minutes to understand what should I focus more on. I can focus on a particular chapter, concepts, do multi-concept problems, but I need your feedback. I want to understand from you where you need help. So, how many of you, those of you, moment of inertia, okay, Parth, ठीक है, center of mass, moment of inertia अभी कर लेता है, ठीक है. Any other suggestion? Children, please open your mic and tell me what you want to learn. I will focus on those areas more. We have less time. I do not want, I am teaching something and you are not getting it. So if you interact, if you speak, I will be able to help you more. So I request unmute yourself and express. Multi-concept, more effective revision, everything will get covered. Yes, that's a good suggestion, Aram. I will do that. I will do that. Especially tricky conceptual things which you think we will get wrong. Yes, I'll come to that. Good suggestion, Lavanya. Tricky one. Okay. PYQs. Okay. Let's do that. Let's do that. ठीक है. चलिए, अब देखिएगा. तो I do agree कि instead of just doing focusing on moment of inertia chapter right now, uh, uh, I will prefer. I have a moment of inertia ka recorded lecture on YouTube channel, so I request this child who is facing that problem, you can get access to. You must be having access to Pace app, and you can see the lecture there for moment of inertia if you are weak in that. Right now, I think this is more advisable as Lavanya, Arham, and Sanat are saying PYQs, multi-concept problems. They will make you more clearer. Okay, chaliye, let me ask you conceptual but tricky questions and easy ones. Okay, everyone clear, attentive. I have a force here, F naught. See, I'll give you a very simple question and let me see how many of you are wrong in that. And there is a point which is at a perpendicular distance P. Perpendicular distance is D perpendicular. Now, यहां से एक एक्सिस पास हो रही है, ये रही, ये एक्सिस है. This axis is parallel. This is an axis. Perpendicular distance between them is D. My question about this is a, for sure, this is a very tricky and interesting and conceptual question for competitive exams. And let me see how many of you are clear in it. What will be the torque of this force about this axis? Tell me the answer. And I am giving you four choices also. It'll be F naught into perpendicular distance D clockwise. Clockwise means this, and this means N cap. N cap into the plane of the board. So torque is this. Second is torque is minus N cap, opposite direction about this axis. Torque about this axis, I am asking. Torque about this yellow axis, which is parallel to the force. Third is 0. Fourth is can't say. Let me see. How many of you can answer this? I want to see all of you. How many of you are conceptually strong? It is an interesting question and it'll make your concept more clear. Please tell me quickly. 1, 2, 3, 4. Just type your answer here. फंस गए आप लोग. You people are doing mistake in a mistake. Double mistake. Wow. So Lavanya corrected herself. So Lavanya, you have corrected. Mistake within a mistake, you have corrected. So now you are doing a mistake. All of you are wrong. All the answers that I've got till now are wrong, and you will appreciate when I'll clear this. You will appreciate. Sahana, Vrushi, Sahana. Oh, Malikarjun. Oh my God. Malikarjun, you are that intelligent. Earlier you were saying you don't know this. Malikarjun, I would like to hear from you. Why did you say 0? Quick. Why is it 0? You said third option. Can you explain to me why is it 0? Malikarjun, unmute yourself, yaar. You can speak. Okay, children. The correct answer is C. And very unexpected, but true. This is the correct answer. And it is conceptual. Now just see the difference. There is a thing called torque about a point, and there is a thing called torque about an axis. And there is a difference between them. Same way, there is a thing called angular momentum about a point and angular momentum about an axis. And you have to understand all these four things right now. This concept is very confusing for most of the children. And they all give this answer.
Component cos 90 equals to 0.
Yes, yes. Who spoke?
So Parth.
Parth. Yes, very good. So if I would have asked you that this is the point P here, and I would have asked you find the torque of this force about this point, about point P, then what you do is you take any vector on the line of force, any vector, the way we used to do it in angular momentum. Same story. You take this vector, or you take this vector, or you take this vector, anywhere on the line of action of force. And you say, if this is R1, you will say torque of this force about P, torque about P is R cross F. This is the torque of a force about point P. And this will come out to be force into perpendicular distance. And the torque direction will be, just see this very clearly. Take both the vectors to the same common point, place their tails together, shift them anywhere in space, but bring their tails together. This is force, this is R1. R cross F will be clockwise in this direction, and that means into the plane. That means torque about this point is into the plane of the board, and that is N cap. So this is the answer for torque about point P. Everyone, please try to understand this. So A is the answer for torque about point P. If you would have chosen any other point on this axis, any other point, it would have been the same. यहाँ पे Q, Y, Z, X, any point, M, N, O, P, whatever. For every of these points, the torque would have come out to be this. So this is the torque about of this force about point P is the answer. Point P. This is the answer for this. But this is not the answer for the axis. This axis, if I want to find the torque about an axis, ये वाली axis, वो अलग, that is a separate thing. This thing you have to get clarity about, and it is a concept on its own. Similarly, you have an angular momentum about a point and angular momentum about an axis. And it's important to understand this. And I will not be surprised if you find it in competitive exams, because they ask a lot of questions based on angular momentum. And it is a very objective and a very simple concept which generally children are confused about. Now get this clarity. What is torque about an axis is, what is the, okay, let me tell you. So I am explaining the concept and you will then answer it properly. The concept is this. If you have any force F and vector form, and you have any point P, and you want to find the torque about point P, you join the R vector, join the point on the line of force anywhere. And if it is R cross F will give you the torque about point P. Torque about P will be R cross F. And it will come out to be always force magnitude into perpendicular distance, and the direction will be N cap into the plane. Okay. This everyone is clear. All of you know things till here. Now I am explaining to you torque about an axis. Suppose there is any axis. Say this is an axis in 3D. Right now it appears to be parallel. Okay, I am saying it is in 3D like this, not necessarily parallel to F. So this is an axis, and I want to find a torque about this axis. And I told you I am giving you a unit vector about this axis is N axis. It is a unit vector. To specify this direction, I'll give you a unit vector. I cap, j cap, say, suppose I say 2 I cap plus 3 j cap minus 1 k cap. So I divided by its magnitude will give you a unit vector along this axis. 2 square plus 3 square plus 1. Now, suppose I give you a unit vector in space, this is an axis, and you have to find the torque of this force about this axis. And P point, this axis is passing through point P. So I'm telling you the method. The method now to find torque about this axis is, first you find a point on that axis. Suppose I chose that point to be P, just to make your life easy and make you understand. So the axis about which you have to find the torque, you choose a point on that axis and find, suppose I chose point P, and find the torque about point P, which we already did. We already know torque about point P. And that torque has a direction, and that direction is into the plane like this. Okay. Now you find the component of that torque along this axis. That component, to find the component of the torque about point P along this axis, you will do what? Dot product with this unit vector. So the moment you do this, torque about this axis will be tau P, torque about point P, dot product with unit vector along the axis. Please note it down. This is a very important concept. This will give you torque about an axis. Please note it down. I'll come back to the previous question that we were doing. Just note it down. This is the torque of a force about an axis. And it is different from torque of a force about a point. What you do is you will do it in two steps. First step will be find the torque about any point on that axis. ये फाइंड कर लिया, वो हमने पॉइंट चूज किया P और हमने उसके अबाउट टॉर्क फाइंड की. सेकेंड स्टेप इज you find you find the component of that torque along this axis. जिस axis के about torque निकलवा रहे हैं. So torque about axis will be tau P dot unit vector along the axis. Please note these two steps. And now let's go back to this question. It's a very interesting concept. Now, tell me one thing. Here, suppose I wanted to find the torque about this axis. I found the torque about this point P, and we already know the value. This is the torque about point P. This is the torque about point P. And it has a direction into the plane. It has a direction into the plane of the board. Okay, clockwise torque. Now, I want to find the component of this torque about this axis. So, what is the angle between this torque and a unit vector along this axis? Can you tell me? What is the angle? This vector is into the plane of the board, this vector. And this axis is in the plane of the board, parallel to. Call Neha. I think the voice. Is my voice clear to all of you? So the angle between them is 90 degrees. So when you will do the dot product, cos 90 will come and cos 90 is 0. So the torque about this axis will be tau P dot unit vector along this axis, say I cap. And the angle between this and this is 90. So dot product will come out to be 0. And now, please get this clear. Okay, torque about this axis will be 0. How many of you understood this? I want to be very sure. How many of you understood torque about a point, torque about an axis? मेरी आवाज गूंज रही है क्या बच्चों? Is my voice clear, or there is some reverberation?
Sir, repeat again.
Is my voice clear?
Yes, sir.
Okay. Now, how many of you understood this concept of torque about a point and torque about an axis? कैसे निकालते हैं? Okay. Parth. Who else? Who else understood this? Lavanya, Aram, good. Malar, Kadam, good, 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 good. Good. Now let's do. So this was a very simple but conceptual question. There is a child who said repeat again. Who was the child? Please tell me again.
Sir, Humera.
Okay. Please pay attention. I will repeat it again with a example, with a question, so that it is not boring to others and still all of you are understanding it. See, have you seen a door in 3D? Suppose this is a door. This is the vertical axis and this is like a door. This is a door. Now, this is the hinge about which the door is rotating. If I exert a force parallel to this axis, this is the axis of rotation of the door, you will be physically able to visualize what I just taught you theoretically. Here is the axis of rotation of the door. Axis of rotation. Yes. Axis of rotation. Why is it happening? Of the door. This is the axis of rotation of the door. The door will open or close about this axis. यहां तक आप सब विजुलाइज कर पा रहे हैं. Okay. This is a rectangular door. Suppose I apply a force which is parallel to this axis. ऐसे आप इमेजिन करिए, वर्टिकल एक्सिस है दरवाजा, द डोर इन योर रूम. If I apply a force which is parallel to this axis, will it make the door rotate about this axis? Will it open the door or close the door? Yes or no? The torque of this force about this axis will be zero. It will not rotate the door, even though it has a torque about any point. If I choose this point P, the torque of this force about point P will be force into, suppose this distance, perpendicular distance is D perpendicular. So the torque of this force about point P is F naught into D perpendicular. This is the torque about point P. And it has a direction. The direction is, if I assume it to be y-axis, if I assume it to be x-axis, this is y, this is x, and the third dimension. So K. So this will be torque R cross F, and we can write R to be this. R will be D perpendicular I cap. Force will be R will be D perpendicular I cap. Okay. Force in IJK can be written as, force can be written as minus F naught J cap. So the torque will be about point P will be R cross F, which will be F naught into perpendicular distance I cross J. What is I cross J? K. So F naught into D perpendicular K cap. This will be the torque about point P. But the torque about this axis will be zero. This is the difference. And how do I specify that? This axis, unit vector along this axis is J cap. If I find the dot product between this, so torque about this axis will be equal to torque about a point on that axis and the dot product with a unit vector along the axis. Unit vector along the axis is J cap. Now, this will be F naught D perpendicular K dot J. And what is the angle between K and J? 90 degree. So dot product cos 90 is zero. So torque about this axis is zero. Just explain to you physically also that if you apply a force on the door which is vertical, parallel to the axis of rotation, it will produce zero torque about this axis, even though it has a torque about the point, every point on that axis. Try to understand this. How many of you got it clearly? Lavanya says not rotate. Good, 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 good. Now, the similar parallel analogous behavior is there in angular momentum about a point, angular momentum about an axis. And this may help you in a lot of exams. Okay. Now let's move ahead and do something more tricky, conceptual. Let's see. There was a very easy question in IIT recently in advanced exam, even though children find it very difficult. Trust me, if you have understood this angular momentum of a rigid body, how to write, you will do it in 2 lines. The question was this. I will be very happy if you answer it after. This is a disk, and this disk is fixed to an axis, and this disk is free to rotate about this axis. Vertical axis. The mass of the disk is m, radius is r. And this disk has a axle fixed to one of its end. On the circumference, there is a axis like this. A pin is fixed to this disk. And then there is a motor shaft attached to this, और वो मासलेस है, वो मोटर जो है मासलेस है. तो ये जो पिंक कलर की है, इसको आप ऐसे मान लो ये एक मासलेस मोटर अटैच्ड है जो घुमा सकती है. नाउ, and there is a disc attached to this, and that disc is like this. उस डिस्क का रेडियस शायद कुछ r/4 था, and mass of that disk is also small, same. So obviously this disk has higher density. It is possible. Okay. This disk is also like this, attached to this shaft. शुरू में सब कुछ रेस्ट में है. एवरीथिंग इज एट रेस्ट. अभी क्या हुआ? तो अब आप ये समझ लीजिए कि ये जो डिस्क है, बड़ी वाली डिस्क, ये जो डिस्क है, इसकी सरकमफ्रेंस पे एक मोटर का शाफ्ट है ये, and this motor can rotate. Motor is massless, and this disk is at rest. Both the disks are at rest, and this disk is free to rotate about vertical axis, this axis, and this disk is free to rotate about this axis, and this axis is fixed to the ground. ये वाली axis. ठीक है. Now, लेकिन ये जो एक्सेस है ये इस डिस्क के ऊपर है, ये वाली. ओके. Now the question in ये IIT advanced का, this question came in IIT JEE advanced exam. Very good question. Children whose concept is clear about angular momentum will do it in 2 lines. And let's see. So what they are saying is, Acha, I have a question. What is the, everything is at rest. What is the angular momentum of the whole system, both the disks, about this axis, OO dash, initially? Before anything happened. Initially, when everything is at rest, can you tell me what is the angular momentum, spin angular momentum of this disk about its own axis initially? Initially, everything is at rest. So, spin angular momentum of this, so angular momentum about OO dash, we are finding for the whole system. What is the angular momentum of the bigger disk? Quick. Yes. Lavanya, correct. But the way I explain torque about a point and axis, that should be understood by you, because that is a more generic thing. What you have stated is a particular case. Ye true hai, what you have written. Okay, now come back to this question. What is the angular momentum of the whole system initially? Initially, none of the disk is rotating, so their spin angular momentum both are 0. Plus 0. There is no orbital angular momentum because there is no motion happening. So everything is 0. Orbital plus spin for both is 0. Is everyone clear till here? Now I am stating the question which came. The question is, मोटर को ऑन किया और मोटर ने रोटेट करना शुरू कर दिया विद एन एंगुलर वेलोसिटी ओमेगा, इस डिस्क को, ये ओमेगा नॉट है, ये बोला है। मोटर का स्विच ऑन किया और मोटर ने इस डिस्क को ओमेगा नॉट से रोटेट करना शुरू कर दिया है। मोटर इसी डिस्क के ऊपर है, बड़ी वाली डिस्क के ऊपर। नाउ, और ये बड़ी वाली डिस्क इज फ्री टू रोटेट अबाउट दिस, और ये एक टेबल पे ऐसे रखी हुई, मान लो फ्रिक्शनलेस टेबल पे, कि गिरेगी नहीं ये ऐसे वर्टिकली या टर्न नहीं करेगी। नाउ, इस एक्सिस के अबाउट रोटेशन इज फ्री। द क्वेश्चन वाज कि क्या बड़ी वाली डिस्क जो रोटेट करेगी, बड़ी वाली डिस्क की ओमेगा डैश क्या होगी, ये निकालना था। दिस वाज द क्वेश्चन। अगर मोटर ने छोटी वाली डिस्क, इफ द मोटर स्टार्टेड रोटेटिंग द स्मॉलर डिस्क with omega naught, what will be the, yeah, motor is fixed to the disk circumference, aram, circumference of the, this motor is here, this is motor here, and it is fixed to the circumference of the bigger disk, but it is on the bigger disk only. If the bigger disk rotates, the motor will also move along the circumference. So motor is massless and fixed to the circumference of the bigger disk. Okay, this is motor. Now we switched on the motor. Motor started rotating this disk with omega naught, smaller disk. What will be the angular velocity of the bigger disk? This was the question of IIT JEE Advanced. And it can be done in two lines if your concept is clear. I already gave you a hint that initial angular momentum of the whole system, both the disks, is zero. Okay. My question to you is, finally, will we be able to conserve angular momentum of the whole system about OO dash? This is my question. Just answer this. Can I conserve angular momentum about this axis of the whole system? Yes or no?
Excuse me, sir.
Yes.
So what's the initial question about, like my internet got disconnected, sir?
Okay, bache. What's your good name?
Parth.
Parth. Question is IIT JEE Advanced question. Just 1 or 2 years back, it came in IIT JEE Advanced, and it is a very conceptual question. K, there is a bigger disk of mass m radius r, which is free to rotate about OO dash, a vertical axis. This axis. This bigger disk is free to rotate about this axis, hinged here. And it is kept on a horizontal frictionless surface or something like that, and it is like a hinge which is passing through it. Now, there is a motor attached on the circumference of this bigger disk, along with a disk of smaller disk of mass m radius r by 4. This radius is r by 4. Smaller disk. And this smaller disk is free to rotate about this axis, and it is attached to a motor shaft. Motor is on the circumference of this bigger disk, and motor is massless. Now we switch on the motor, and motor starts rotating this smaller disk with omega naught. This is given. So omega naught is given. This angular velocity is omega naught. Okay. You have to find when it starts rotating with omega naught, will the bigger disk will also start rotating or not, and what will be the angular velocity of the bigger disk? This is the question. What is the angular velocity of the bigger disk? My question is, can I conserve angular momentum of the whole system about this axis? Yes or no? Just answer this. Yes, we can conserve the angular momentum of the whole system about this vertical axis O dash. Why? Because all the forces, this bigger disk is free to rotate about this axis. So there is no torque acting about this axis. If external torque is zero about this axis, we can conserve the angular momentum of the whole system. This smaller disk and bigger disk are together. So they can be treated as one system, and therefore I will conserve angular momentum about OO dash of the whole system of big disk plus small disk, which are connected together. They can be considered as one system. This will be conserved. This is the argument that you need to understand. Once you are clear about it, you will be able to write the equation. Initial angular momentum of the whole system was zero. Finally, also it should remain zero. Finally, let's write down for the smaller disk. We are finding angular momentum about this axis. Everyone be clear. So angular momentum of the smaller disk about this axis will be what? Quick. Spin angular momentum of the smaller disk कितना होगा? Spin m r by 4 का whole square mr square by 2 I omega naught. This is the spin angular momentum of the smaller disk. Spin angular momentum for small disk. Okay. Plus, what is the orbital angular momentum of this small disk? If I have assumed that the bigger disk is rotating with omega dash, अगर ये ओमेगा डैश से घूम रही है, तो आप मुझे बता सकते हैं इस डिस्क का जो सरकमफ्रेंस का हर एक पॉइंट है उसकी वेलोसिटी क्या है? इस पॉइंट की वेलोसिटी बताइए जरा। डिस्क का जो ये पॉइंट है, अगर ये ओमेगा डैश से रोटेट कर रही है, तो डिस्क के इस पॉइंट की वेलोसिटी क्या है? सरकमफ्रेंस पे जो पॉइंट है, क्विक। वेलोसिटी ऑफ दिस सरकमफ्रेंस वाला पॉइंट क्या होगी? वी विल बी आर ओमेगा डैश, यस और नो? आर ओमेगा, करेक्ट पाथ, परफेक्ट। इफ दिस इज द वेलोसिटी, तो क्या, व्हाट इज द वेलोसिटी ऑफ द सेंटर ऑफ मास ऑफ दिस डिस्क? सेम। व्हाट इज द ऑर्बिटल एंगुलर मोमेंटम ऑफ दिस स्मॉलर डिस्क? Orbital angular momentum of this smaller disk, it will be mv into perpendicular distance. Perpendicular distance is r. So you will say this plus mvr. M is m into v is r omega dash into r. Yes. This is the orbital angular momentum of the smaller disk. Please note it down. Every term should be clear. Orbital angular momentum for smaller disk about OO dash axis. We are finding total angular momentum initially was zero about OO dash. We are finding final angular momentum about axis OO dash. So for that we found the angular momentum due to smaller disk plus what is the angular momentum of the bigger disk? For bigger disk, spin angular momentum is how much? mr square by 2 into omega dash. This is the spin angular momentum, L spin. And what will be the orbital angular momentum of the bigger disk about this axis? Orbital angular momentum of the bigger disk about its own axis of rotation will be mv into perpendicular distance of the center of mass from that axis is zero. MVR will be zero. So this is the spin and orbital will be zero. So this plus this. So total angular momentum becomes, and all three are in same direction, you can see, as we have shown. Now, if omega dash comes out to be negative, that will mean the bigger disk is rotating in opposite direction. If it comes out to be positive, it will mean it is rotating in the same direction. And now just equate these two. Initial angular momentum 0 should be equal to this whole thing. and this one line will give you the value of omega dash, and that will be the answer. And it was a one line question of 5 marks. Sochi, 4 or 5 marks. If you are clear in your concept, how many of you understood this? Please give me a thumbs up. Nice. Parth, Arham. It is not tough. Till the time you do not know a concept, you will find a question tough. Once you, okay, let me modify this and let me see how many of you actually, Lavanya, understood. Okay. I will give you a question, interesting question, conceptual question. This is a big disk, mass m radius r, and this is free to rotate about this axis. Horizontal, frictionless, stable. Okay. Now, the disk is free to rotate about OO dash. I want immediate answers, quick answers. I just want to strengthen this concept of yours. And I bring a smaller disk. इसका मास है m/2, रेडियस है r/2. This smaller disk was rotating initially. There is no motor here now. This smaller disk was initially rotating about this axis with omega naught. And I slowly, gently bring it down and place it on the disk, bigger disk. There is friction force between both the disks. Friction exists, is there between the disks. But there is no friction between the ground and the bigger disk. This is frictionless. Table is frictionless. Now, I place it gently on the bigger disk. After some time, both the disks will be rotating with same angular velocity. You have to tell me what will be that omega. Common omega क्या होगी? देखते हैं how many of you will be able to do it. And I want a quick answer, quick response. Quick. Aram, please, I want response. My question is the friction force that will act between the disks here, when they will get in touch with each other, there will be friction acting between these contact points here and here, everywhere. Okay. But can I consider that internal force? Can we consider that friction force which is acting between the disks to be their internal force? If I assume both of them as one system, that is internal force. External force about this axis O dash is zero. So external torque is also zero. About O dash is zero. If external torque is zero, I can conserve angular momentum. If I can conserve angular momentum, so you will say initial angular momentum of the smaller disk is only spin angular momentum. Orbital is zero. Spin angular momentum will be m/2 m r square by 2 into omega naught. This is the spin angular momentum of the smaller disk before they are placed in contact. Spin angular momentum of smaller disk. I am being explanatory, assuming that I want to give full clarity to you. What is the orbital angular momentum of the smaller disk? Zero, because there is no velocity of the center of mass of the disk. And even if there was velocity, it is passing through this axis only. So angular momentum would have been zero. Okay. For the bigger disk, there is no spin initially. Zero. Spin also, orbital also. Okay. This is the total angular momentum of the system before they are connected, kept on each other. Finally, both of them will be spinning up with same angular velocity, and let that angular velocity be omega dash. And quickly you will write for both the disks. Moment of inertia for the smaller disk is m by 2, m r by 2 whole square by 2, plus for the bigger disk it is mr square by 2. This is the combined moment of inertia, and into omega dash, because they both have same omega. So I net into omega dash will give you, and this is the answer. This gives you the answer. One equation. How many of you energy is not conserved? Yes. Angular momentum is conserved. Energy is not conserved. Why? Because there is friction force which is non-conservative force. So you cannot conserve energy. Now, Lavanya, if I ask you a question, देखिएगा कितना टफ क्वेश्चन लगेगा अगर आपको इसको, इफ यू ट्राई टू डू इट बाय फोर्स मेथड, torque method, and try to, if I ask you what is the work done against friction force, there is slipping happening, there is kinetic friction acting between the two disks, and I have asked you in this same question, I have asked you what is the work done by the friction force during this whole process. When initially small disk was rotating with omega naught, big disk was at rest, then I placed them gently, and finally they started rotating with same omega dash, and that omega dash we have calculated here. This is that omega dash. Now, after they have achieved omega dash, they will continue moving, rotating about this axis with omega dash, and there will be no loss of energy further because kinetic friction has stopped. Uske baad, they are moving together, rotating together. Okay. My question is, there is work done by kinetic friction during this process of slipping between the two disks. Can you find out that work done? Let me know who all can find out that work done. So we will apply work energy theorem and get the answer in one line. Initially, the kinetic energy of the smaller disk was how much? Initial kinetic energy of the smaller disk. Bigger disk was zero. For the smaller disk, it was half I. I is m by 2 into r by 2 mr square by 2. This is the I, half I omega naught square. This was the kinetic energy of the smaller disk. Now, the kinetic energy of the whole system after, this is kinetic energy before. Now let's write down kinetic energy of the whole system after. And this kinetic energy will be lesser. And that will be half I of the small disk plus I of the big disk. They will move together with omega dash. So omega dash square, half I omega dash square. This is the kinetic energy after. Now the kinetic energy has decreased and this loss in kinetic energy. So kinetic energy before minus kinetic energy after. This loss in kinetic energy is equal to the work done against friction. And that's the answer. I will really appreciate those of you who have understood this. Give me a thumbs up. Okay, how we found the work done against friction without using Calculations, calculus, Aram understood it. Any other person who understood it? Give me a thumbs up. Parth, very good. Lavanya, did you understand it? Linear, yes. Angular, no. Okay. Hmm. Okay. Those of you who understood this, give me a thumbs up, please. So that Bhumika. Okay. Who else understood this? Okay. Aram, Bhumika. See, I will enjoy Vishwas. Good. If there is more participation of the class. Right now, I'm not getting that vibe, that feeling, because for me to tune in to your needs, whether to make the level of difficulty more Manju, okay, you got it? ठीक है. So I've got few thumbs ups. Assuming that you are getting this concept, let's do few more problems and let's see. So I have given time to angular momentum, torque. Okay, let me ask you a question where I will get full clarity about your mechanics. It will involve multiple concepts, and let's see how many of you answer it right. Okay. The question is like this. I'll still go step by step. So first we'll do one level of difficulty, we'll go to the next level, and then I'll see how many of you are with me in this. Those of you who have played snooker, क्या बोलते हैं उसको? पूल. हाँ, snooker बोल. Hmm. Now, so this is a ball, solid ball of mass m, radius r. Mass m, radius r. Now, it is given certain velocity v naught initially. It's a solid ball. And the ground is rough. There is friction. The ball had zero angular velocity initially. Zero. Omega was zero initially. And it was given only v naught and gently kept on the ground. Now, can you tell me what will be the velocity of the lowest point of this ball initially? Will it be v naught or not? Superimposition theorem. Yes. If it will be v naught, will there be friction acting between the ground and the ball? Yes. Friction force will be acting in this direction on the ball. F, friction force. And will it be kinetic or static? It will be kinetic. Yes, and kinetic. Good, good. This is the response I want. Now, Aram, please pay attention. This friction force will exert some torque about the center of mass, and that torque will be F naught into R, and it'll try to increase its angular velocity and decrease this velocity. इसको decrease करेगा, ओमेगा को जीरो से बढ़ाएगा, ओमेगा को, और वेलोसिटी को, ये जो वेलोसिटी राइट की तरफ है, इसको डिक्रीज करेगा फ्रिक्शन अपोजिट डायरेक्शन में, और धीरे धीरे ये बॉल की वेलोसिटी कम होती जाएगी, ये आगे चलती रहेगी, इसकी वेलोसिटी कम हो जाएगी, और ये एंगुलर वेलोसिटी ओमेगा बढ़ती जाएगी, एंड इट विल रीच अ पॉइंट हियर where VCM is the velocity, new velocity, VCM, and angular velocity will be there, omega cm, such that there is pure rolling happening. Now it has started slipping, stopped slipping. The slipping has stopped. Finally, after some time, the slipping has stopped and it is doing pure rolling after some time. Pure rolling. My question is, when it has started pure rolling, what is VCM and what is omega cm? Try to find it out. These two. Try to do it on your own. I want to see. Pure rolling will start after some time. You have to tell me when pure rolling has started, what is velocity of center of mass and angular velocity about center of mass at that moment and after that. So after that, it will remain constant because friction force kinetic will become zero and it will continue doing pure rolling. You have to tell me what is that pure rolling velocity and omega cm, VCM and omega cm when pure rolling has started. Initially, they were slipping. Let me see how many of you can answer it right. Hmm. Hmm. Anyone done? Hmm. Anyone done? All you have to do is, in this case also, conserve angular momentum of the ball. Just see this. The beauty of this question is, let's choose a point here on the ground here. This is a point I'm choosing. Red point, this point. Please tell me, let's make a free body diagram of this body and mark all the forces. The forces acting on this body will be, with green color I'm marking, there will be weight, mg. There will be contact force, normal reaction, N. and there'll be this friction force. These are the three forces. We all know N will be equal to mg. Why? Because there is no vertical acceleration. Therefore, mg is equal to n. Okay. Now, if I want to find the torque acting about this point, O, torque about O for this whole system of this rolling ball, the torque about O will be due to these three forces which are marked with green color. Torque due to mg and normal reaction will cancel each other because the perpendicular distance is the same. Mg into perpendicular distance, normal into perpendicular distance, and both are equal and opposite. Therefore, their torque will cancel. And torque due to kinetic friction force will also be zero because it is passing through this point. Okay. Now, net torque about O, net external torque about O is zero. Therefore, it implies angular momentum of the ball about point O on the ground. Angular momentum about O will remain conserved, will be constant, will not change because external torque is not there, will remain constant. If you have understood this logic, then it is a one line problem. What is the initial angular momentum of the ball? Initially, there is no spin. So angular momentum due to spin, L spin is zero initially. Spin angular momentum. And orbital angular momentum, initially it is moving with v velocity. So perpendicular distance is r. This is the perpendicular distance on the line of velocity. You will write mv into m v naught into r. This is the angular momentum and it is clockwise, about 0.2, clockwise into the plane. Okay. Should be equal to the final angular momentum. The final angular momentum, when it has reached and has got VCM and omega cm, is 2. Spin angular momentum is 2 by 5 mr square. This is I into omega cm plus orbital angular momentum now will be the line of velocity, perpendicular distance is r. So you will write mvcm into r. This is conservation of angular momentum about O. And why did we conserve angular momentum about O? Because there was no external torque acting on the system about O. Second is condition of pure ruling is also due to superimposition, we can find out the velocity of the point of contact. Velocity of the point of contact here of the ground point has zero velocity. The point of the ball can be, we will use superimposition theorem due to translation VCM, due to rotation R omega cm, and the net velocity will be VCM minus R omega cm should be equal to zero. So VCM should be equal to R omega cm. These are the two equations, and we have two unknowns, VCM and omega cm, and we can solve it. Now, how many of you understood this? Give me a thumbs up. Those of you who understood this, okay. Manju. Who else understood this? Give me a thumbs up. Okay. Children, what I request you now is, what you people need to do is, at this stage, I feel, okay, there was a child who wanted to know about moment of inertia. There are things which I wanted to explain to you. Collision, rotation. So quickly, I'll go through the key concepts of rotation and this collisions. I, in the last lecture, explained about collisions properly, and Uh, hmm. Let me do one more conceptual question where I will test your previous skills also, free body diagram also, everything. Now, this is a conceptual question. Please pay attention. Even though it will appear to be little easy, but it won't be easy. There is a cylinder of mass m, radius r, solid cylinder. And there is a plank which is kept over it of mass m2, m2 mass. This is kept, cylinder is kept on a horizontal surface which is rough. So there is friction everywhere. Friction is everywhere so that there is no slipping happening. Friction is there, but no slipping is enough to ensure no slipping. Now, my question is, and this ball has a radius m and r. This radius is r, mass is m1. Okay. This is m2. I am pulling this with a constant force F naught. And I am pulling it with a constant force F naught, and there is no slipping happening anywhere. If there is no slipping, the friction force will be kinetic or static. Please reply to that. The kinetic friction will be acting or static friction will be acting. Just answer that between the surfaces.
Static friction.
Very good. Static friction. And that static friction will be, suppose F1 here, suppose that friction force here is, when static friction is acting, we don't need to worry about the directions. We can assume any direction, but here we will assume that the plank has that static friction force is F1. So there'll be equal and opposite friction force acting on the sphere F1. Okay. There will be some friction force acting on this sphere here. I can assume towards right also, towards left also. Doesn't matter. On its own, it'll adjust, and the answer, if it comes out to be negative, will mean that we have assumed opposite direction. Now, this is F2. Okay. These are the static friction forces. Now, my question is, what is the acceleration of this sphere, cylinder? What is the acceleration? ACM, and it will have an angular acceleration omega cm. You have to tell me what will be the acceleration of omega cm and ACM. What will be the value? Find omega cm, sorry, alpha cm, angular acceleration, and linear acceleration of the cylinder. Try to do it. Now, this will involve free body diagram, friction, equation for torque, everything it will. So just try to do it. Let me see how many of you can do this. Is there any child who feels he's able to do it? Okay, let's quickly write the equations and you will understand. Just pay attention. I want you to understand the concept, not the calculations. Suppose the acceleration of this plank is A2. A2, ACM and omega CM, alpha CM, they are linked. Alpha, ACM and A2. All three of them are linked. We will know how they are linked. They are called equation of constraint equation and we'll write them down. First, let's write down the equations of motion according to Newton's laws. For this plank, equation will be horizontal direction F naught minus F1 is equal to mass into acceleration. This is correct. For cylinder, F1 minus F2 horizontal motion is equal to mass into acceleration ACM. Okay. For rotational motion, net torque about the center of mass due to force F1 will be clockwise and it will be F1 into R. Due to this force F2, oops, what happened? Due to force F2, the torque will again be clockwise and the perpendicular distance is R. And both will be clockwise. So F1 into R plus clockwise, I'm assuming to be positive, F2 into R net torque is equal to I alpha. I is for solid cylinder M1 R square by 2. Net torque is equal to I alpha CM. I've got three equations. One is the translational motion of the plank. Second is the translational motion of the cylinder. Third is the rotational motion of the cylinder. Three equations. I need two more because I have five unknowns. What are those five unknowns? Please get this clear. We have A2, we have ACM, we have alpha CM, we have F1, we have F2. We have five unknowns. We need five equations to solve. Number of equations and variables should be same, but we have got three only. Who can suggest me the remaining two equations? They will come from constraint, point of contacts, superimposition theorem. And I did this question for that purpose. Just see this. Let me name this point as point of the cylinder in contact with the ground. I am naming it as 1. And point of the ground which is in contact with the cylinder, I am naming it as 2. What is the acceleration of point 2? 0. What is the acceleration of point 1? I will find out from superimposition theorem. What does superimposition theorem say? Acceleration due to translation will be ACM and due to rotation will be R alpha CM behind. Net acceleration will be vector sum. So it will be ACM minus R alpha CM should be equal to 0 because these 2 points are in contact and therefore there is no slipping happening. Their accelerations has to be same. This is fourth equation. Now, fifth equation will come from here, this point. Let me name this point as 3, the point on the plank in touch with the cylinder, and name the point of the cylinder in touch with the plank as 4. Acceleration of 3 and 4 should be same because they are not slipping with respect to each other. So that is the constraint. Acceleration of 3 I already know. What is the acceleration of 3? A2. Yes, should be equal to acceleration of 4 can be found by using the superimposition theorem. Due to translation, it will be ACM in this direction. And due to rotation, rotation is happening this way. So due to rotation, it will be again in the same direction and it will be R alpha CM. Now vector sum of these two will be ACM plus R alpha CM should be equal to A2. This is my fifth equation. Now you have got five equations and five unknowns. You will be able to solve it. Again, it was an IIT advanced question. Again, there is nothing tough about it. Net force is equal to ma. You have learned it right in the beginning. Net torque is equal to I alpha is a parallel analogous behavior in rotational motion. So net force is equal to ma, net force is equal to ma, net torque is equal to I alpha. These three are simplest of the equations. And the two equations which we got from constraint, point of contact, we got from superimposition theorem. I've tried to highlight the importance of it, and I've tried to explain to you how we find them. And this is how you have to do this. Now, you can see in collisions also, here also, at so many places we use that superimposition theorem to find the velocity of the point of contact. So all of you should get used to it, understand it, and I expect that if you people have any doubts now, I am opening the session not to be just like a monologue. If you have any question in your mind about anything, please feel free to ask. Children, one thing I would like to say, this is like the final stage. Next 15, 20 days, little time that you have. Every day, every hour that you are using should be very well planned. Do not invest your time in just doing 20 questions or 50 questions on one topic. Invest your time judiciously in learning the concepts, seeing few solved examples quickly, and then moving ahead with practicing some questions also. And instead of just getting into the calculation and multiplying 3.98 into 9.81 into 7.23, don't waste time on that calculation part. Right now, focus on conceptual clarity. Right now, focus on speed and plan your time well with whatever knowledge you have, with whatever learning you have had till now. If you deliver your best in the exam, trust me, everyone is a human being. We all have inefficiencies, children of your age. There will be 100, 200, 500 students across the country who are bookworms, who are day and night studying for last 2 years consistently, but not, they are also human. They also have inefficiencies. They are also lazy. Don't underestimate yourself. Do your best, optimize your time, and give your best performance. That performance will finally surprise you when you will see that you are doing. Even when I was in my village, I never expected I'll get selected in IIT. But the only thing पता है, I was very, वो बोलते हैं ना, ignorance is bliss. I'll explain this to you. So I was an average person in studies. I never used to study. So I was very clear that I don't work hard, so I don't get marks. But the day I'll work hard, I understand logic and I will get marks. When I started studying, the logic started fitting. I started getting the concepts. Now I was a very lazy person. So I didn't want to work too hard. So the logic that I used was my name must be in the Guinness Book of World Records to get into IIT for getting into IIT with least amount of hard work ever. So मेरा logic था कि IIT creates original questions. So none of these books, thick books which we have and exercises and questions are going to be copied from here. So they will have an original question. So I don't need to do every problem existing outside. Then what to do? I will understand the concept of a chapter. I will then see few solved ex-IIT problems, competitive exam problems, and quickly get the hang of it, how this concept is applied in problems. Don't jump to solve the solved examples. The reason solved examples are kept in a study material or anywhere is to make you quickly understand the application of those concepts. And then you try to attempt few problems and try to see whether you have understood the concept properly and you are able to apply it or not. So please be judicious, plan your time well. Self-study is going to be your core. And be confident. Don't lose confidence. Anyone, there are so many children who know more But because they are demoralized, they get stuck in initial few questions and lose the balance of mind. They leave many questions which they know could have easily been done by them, and they leave them at the end because in the first round they got stuck initially in some one difficult problem. Now, examiner doesn't have a balance. Okay, he knows exactly which child will get stuck on this problem. You will take some problems will be easier for you, some problems will be tougher for you. So skip in the first round all the difficult questions. In the first round, you do all the easy questions that you are getting till the end of the paper. So if you give your optimum on that day, trust me, you will be surprised with your results. And I want more interaction. You people are a part of the group which we have made. If you have anything to say, please message me. If you need any help in any topic, please message me. I'm ready to teach you online at any time. All I want is sincerity and communication. So, children, all the best to all of you. Good wishes. And if you feel like taking help in any part of physics, I will be there. In the next lecture, we'll be doing electrostatics and electricity and magnetism. Because time is less, I want to cover on all the important components of all the chapters. So please be prepared. And if you need help in any specific topic, and if you are a sincere child, please do self study and take help from me if you need any help in physics. All the best. Good wishes. Take care. Yeah, my number is there already. 9821226985. I have already put that in the WhatsApp group. I
Sir,
have
98212.
98212. After that, it is 26985. And please text me with your name, your
Thank you.
which center you are studying, and I will definitely revert back to you. Okay? Okay, bachcho. All the best. I am a teacher. I know physics, and you people are sincere people. I do want to help you. Any help you need, please feel free. Thank you. Good wishes, bachcho. Take care.
Thank you, sir.
Take care.